In this video, we're going to look at coordinates and position. In order to describe motion in physics, we need a way of describing the position of an object. In this video, we're going to look at x, y, and z coordinates, also known as Cartesian coordinates. It's a 3D coordinate system that physicists use to describe the position of objects. In the Cartesian system, we use three numbers to represent the position of an object on a grid, as shown here. So whenever we have a coordinate system, we must define an origin. This is where all the coordinates are equal to 0. So in this diagram, it is the central point shown just here. To locate any object, we use three numbers, x, y, and z, separated by commas in brackets. To have a look at this, I have a 3D simulation. So first, we're going to look at the point 2, 2, 0. So the blue line here goes from the origin to the position 2, 2, 0. Note that this point is 2 units along the x-axis and 2 units along the y-axis. But it hasn't moved at all in the z direction. It's completely flat. Now this point shown in the red here, this is a coordinate -2, -2, 4. So it goes -2 in the x direction, -2 in the y direction, and 4 in the z direction. Because there are negative numbers, it means that it goes in the opposite direction on the x and y axes.
Sometimes we only need to consider a two-dimensional coordinate system rather than a three-dimensional coordinate system. For example, a map like this. In this case, we still use coordinates just like before, except this time we only use two numbers in the brackets, x and y. For example, snail racing is at 5 in the x direction and 9 in the y direction, or the coordinate 5, 9. And Hackland is located at the coordinate 2, 3. It is also possible to use one-dimensional coordinates, like this. This occurs when we are considering an object that is just moving backwards and forwards in one direction. For example, we could have this person move across the screen. In this case, they start with the x-coordinate 0 and end with the x-coordinate of 5. And then they can move back 1 again and end up on the x-coordinate of 4. Just this one dimension is enough to describe the person's motion.